Hello and welcome. My name's Lee Atkinson. Welcome to the Taking DevOps to the AWS Edge. So just a brief what to expect from this session. So we're going to talk about how to integrate Amazon CloudFront and other AWS Edge services into your agile development process. So part of your application, rather than seeing it as something that's added onto your application, possibly before you do a launch, actually think of the Edge services as part of your application. To follow best practices around security, performance, and trying to reduce costs, to automate the deployment of your configuration to the Edge services, and to do testing, and to also to monitor and analyze the performance and the usage of your Edge services. So I've got quite a short agenda. So the first thing we're going to talk about and define what the AWS Edge is. I'm going to talk about the application Edge, and then we're going to talk about some patterns for using AWS Edge services to provide a DevOps Edge. So firstly, what is the AWS Edge? So we can start with the AWS Edge locations. So there's 68 Edge locations operating globally. These are the blue dots you can see on this map. The orange dots are the AWS regions. But the Edge locations is where the Edge services operate from. And the Edge locations themselves are located close to users, and it's to provide low latency access to the AWS Edge services. So the AWS Edge services themselves are Amazon CloudFront, our content delivery network, Amazon Route 53, our DNS service, and AWS WAF, our web application firewall. So the application Edge. So I think traditionally we would see our application as being the origin web servers, effectively, that what originates the content for your website or your web application, your web API, and the client itself. So the origin you can see as being EC2, ELB, S3. So they are originating the content for your website. The client can be a web page, a mobile application, a desktop application. So we would traditionally see that is your application. But I want you to think about actually, as well as those two, there's actually the Edge in between. So these are the Edge services, Route 53, CloudFront, and AWS WAF. And as a whole, those three parts make up your application. So to dive in a little bit of how CloudFront improves user experience, we're showing here that we've got the origin servers in the top right, we've got our client in the bottom left, and we've got these AWS Edge locations. Our AWS regions and most of our Edge locations are operating and connected to the Amazon backbone. This provides low latency, optimized communications between the Edge locations and the regions. So let's say we've got a client in the bottom left who's going to wants to download an object. The top right, it's a bar chart. The first thing it's got to do is to find out which Edge location it's going to talk to. And that's part of CloudFront, is to direct that client to the nearest Edge location for the low latency connection. Because it's HTTP, we're using TCP. TCP needs a three-way handshake to establish a connection. And the shorter the distance we can establish this connection, the quicker we can establish that connection. So the closer we can connect the Edge location, the better. Once we've established that connection, we can then make a request to the Edge location for the object. But if the object is not actually stored in the Edge location will go back to the origin to make a request. Again, it's a three-way handshake, and it's going over a longer distance. But the one thing is that once we've established that connection, we'll persist that connection for as long as possible. So any more requests for that origin can use and reuse that connection. So we can then download that object into the Edge location, and we can then cache that content for future requests, and then deliver it to the end client. But let's say there's a second client that connects and wants to request the same object. Again, we've got to do the three-way handshake, but we're doing it over a short distance again, so it can be quick. Now, the object's already in the cache, so we can actually deliver it straight from the cache without even going to the origin. But if it wasn't in the origin, the Edge location can go back to the origin. If the object wasn't in the cache, we can go back to the origin and retrieve it from the origin. We've already persisted that connection. So even if we have to go back to the origin to get the object, it's quicker to go via CloudFront than for the client itself to establish a connection over the internet all the way back to the origin. So CloudFront can also help to reduce costs. So there's free data transfer between an AWS region origin, so that's whether that's EC2 or S3 or ELB. You don't pay for the data transfer from those to CloudFront. And the data transfer out of CloudFront is cheaper than coming out the region as well. So on the whole, you'll save money using CloudFront. Even if you're not caching content, you'll save money to deliver content out of CloudFront rather than straight out of EC2 or S3. And because we can cache content at the edge locations, and because we're reusing persistent connections to the origin, we'll find that we'll actually have less load on our origins, which means we don't need to scale so much, we don't need to run as much infrastructure as at the origin, which also saves money. Amazon Route 53 has health checks, so this allows us to monitor endpoints and update our DNS if we detect there's a problem with one endpoint. So in this example, I've got a DNS record, www.test. I'm pointing it to a single endpoint. Amazon Route 53 health checks will monitor the endpoints that we define, and it will repeatedly monitor those. The monitoring is performed from different locations globally. And if we do detect there's actually a failure, to be able to, the failure of health in a particular endpoint, Route 53 can automatically switch over the record to point to the secondary endpoint. And we can also use this to automate and provide notification of this failure. So we're going to talk about the patterns for the DevOps edge. And these are 5 that I've defined, and we work through each one. So the first one is to cache as much as possible. So I'm going to talk about HTTP cache control. So this is something that's defined in the HTTP specification. Cache control itself is a header, and it can be used in both a request and a response in HTTP. I'm going to talk specifically around HTTP response cache control. So let's say we're going to make our requests again from our client to our origin. So we're requesting for the bar chart. Now the origin, we found the object, the origin's got the object, it's going to return it, and it will add extra headers in its response. One of those can be cache control. Here we're setting a max age of 1800, so that's 1800 seconds, it's 30 minutes. And what this is saying to the client, here's the object, you can cache this content for as long as you like, but if after 30 minutes you want to use it again, please contact me and validate that you've still got the latest version. What it's not actually saying is after 30 minutes, you can delete the object. You know, you can keep that object after 30 minutes, but if you want to use it again, you need to revalidate that you've got the current version. There's also extra directives within cache control. So there's also S max age. So that's a shared max age. That is for a shared cache. So that's a cache that is being used by more than one user. So typically, they are CDNs, proxies, web caches, etc. Probably every cache apart from, say, the browser cache itself, which is obviously only private to that user. We can also specify private, which means you can cache this content, but only the private cache should be caching that content, i.e. only the browser cache or the mobile application should be caching that content. We can also specify no cache. So curiously, no cache doesn't actually mean that you can't cache the content. All it means is you can cache it, but you need to validate every single time you want to use it with the origin to make sure that it is the most valid, most up-to-date version. And no store is saying, don't cache it, don't save it, just send it on, don't store it at all. So we're going to just use max age 1800. And also you have an extra tag sometimes called the E tag, entity tag. And this is a way of marking the content as a specific version of that content. The specification doesn't specify how you can calculate that E tag, But it's very common that people will use hashing of the content, or they'll use a timestamp for the generation. But you should see that as just a piece of string. It's a piece of text. It's not giving you any indication of the content itself. It's just that if you've got two entity tags that are different, that means that the content is different too. So at this point, the origin will send that to the client. And so the client can then use that object for the next 30 minutes. It doesn't need to contact the origin again to use it. But let's say after 30 minutes, it does need to use it again. It will still be in the cache, but it's got to validate, have I got the current version? So this time it will send a GET request, and it will say if non-match. Basically, we're saying, give me the objects, but only if it's a different E tag to the one I've got. So let's just say the object hasn't changed, it's still the same E tag. So the origin can be very efficient. It can say, yes, you've got the correct version, keep on using it. But let's say it has actually changed. So again, we repeat it. We've got if non-match, the same E tag as before. We're saying, please send me the new object if it's changed. And this time it has actually changed. So the origin this time will actually send the object, and will also send a new E tag because it's a different object. So you can see using cache control, E tags, and what we call conditional gets with if non-match, you can be very efficient to validate the object. So you shouldn't be too concerned about having to go back to the origin and validate, because typically it's a yes, you've got the current version, or no, here's the newer version. And Amazon CloudFront itself understands cache control. So you don't need to have to make any modifications to your application. If it's using cache control, CloudFront can just use those, understands all those directives, so it can cache those objects, and it will also act as the server to your client machine and understand when to say 304 not modified, etc. So CloudFront will use the cache control directive for its TTL, how long an object can stay in its cache before it needs to validate again with the origin. But it can also use a configuration as well. So the actual TTL that CloudFront can use is a combination of the cache control headers, but also how you configure it within CloudFront itself. So if a response has max age defined in the cache control header, CloudFront will use that as its TTL. I think I said max age. I mean max age, shared max age. If it's got shared max age, it will prefer to use that. If it hasn't got a shared max age, it will use max age. And if it's got a expires header, it will use that. Now, expires is an older cache control header. It hasn't got as much features as cache control itself. Effectively, it specifies a date and time in the future, at which point the content becomes stale and you need to revalidate it. CloudFront will use that as well to define its TTL. So at that point, if it finds any of those information in those headers, the origin itself has now defined that TTL. But if none of those were defined, it will use what's called the default TTL. So this is the configuration that CloudFront has if there's no specification of the TTL in the header. But within the defined TTL of the origin, we can start to put limits on that. Maybe we want to limit the maximum value that TTL can be. So there's a configuration called max TTL, and there's also one called min TTL, the minimum TTL. So we can constrain the range of TTLs that CloudFront uses. So eventually, and this is for every single response, the TTL is defined for CloudFront to store that in its cache. Now, one thing to think about, the TTL that's been defined is used by CloudFront. If once, let's say that it's used a minimum TTL or a maximum TTL to change the TTL that's actually defined by the origin, CloudFront doesn't update the cache control header. It will still send that directly to the client. So that's a key point to think about, that cache control is great because it allows the origin to be in control, and you can define cache controls very granularly, both within the URL itself, the response, but you can also think about like a time-based TTL. So perhaps you create articles in a news website, for instance. You create an article, quite often that article will be updated. It's breaking news. The article is changing quite rapidly. So you could use a short TTL while that's changing so that the website will display those changes. But as that news article becomes older, it's less likely to change. So you can extend that TTL over time. So perhaps once the news article is maybe a week old, it probably won't change again. So you can extend it to cache it for a long time. So try and think about defining cache control and TTLs within CloudFront. If you're using the origin to define cache controls, you can be very granular, not only with the URL and the object that you return, but also the time and the age of that object. We also want to think about using the client as well as part of our application. So a response that you provide from the origin or from CloudFront can only have a certain level of cacheability. You can't have different elements of your web page, and I mean the HTML part of the web page. You can't cache that slightly differently depending on how static or dynamic that content or how personal that content is. So if we take just a random e-commerce website, if we look at the HTML in that web page, that structure of that HTML is pretty much the same for most users. I mean, obviously the images will change, but the general structure of HTML page would be the same. However, there are certain things that are very specific to me. So these elements here, they are specific to me, but they're relatively static. You know, I will always be a customer since 2000, for instance. And I might change my name. I'm sure I will need to update my photo at some point, but they are relatively static. But there are also dynamic elements within that web page. I would expect if I add an item to my shopping basket, that should change, that should update relatively quickly. Similarly, my orders will change. I expect if my orders change, I would expect to see that change within a few minutes or a few hours or something like that. So because of these elements within this HTML page are quite dynamic or quite personal to me, that would suggest that the whole of that web page can't really be cached a great deal. The cacheability of that page is as cacheable as the least cacheable element. Now, there's some techniques that are used, such as compiling the web page in a proxy in front of your origin, maybe using things like edge-side includes. But again, it still can't be cached a great deal. It's not very cacheable. So think about other techniques is to actually use the client to do the inclusion of HTML elements within your web page. So you could actually cache that HTML element, but perhaps there's a JavaScript call back to the website to bring back extra data and to modify that HTML page. And also to think about content not necessarily being either dynamic or static, but it's a range of dynamic or static. So some things will range from being very dynamic, they're updating and they're changing, stock prices are changing all the time, to static content that doesn't change. But actually content fits along that range. Similarly, private content, personal content, it still can be cached. It's obviously only be cached and served to me, but it still can be cached. But then there's also, as well as personal content for one person or universal content for everyone, there's also content that can be served for a group of users. Let's say a group of users who prefer a particular language, for instance. So the second pattern to talk about is to forward as little as possible. So what do I mean by forwarding? So this is a concept within CloudFront. So if you make a request against CloudFront and it's not in the cache, it's going to make that request back to the origin to get the content it needs. By default, it will always send the path of the request. And that's all it sends. Effectively, it's forwarding the path to the origin, so the origin can return a response to that path. And the path itself is part of the cache key, so that if any subsequent requests come in, CloudFront can look at its cache with that cache key and find the object and return that. But quite often, just the path on its own doesn't give the origin all the information that it requires. As this is an example, this is a search page. We're not actually providing the origin with any query terms, so it wouldn't actually be able to find anything. But by default, the query string is not actually forwarded in CloudFront. But we can enable that. We can actually configure CloudFront to forward the query string. And in fact, we can now specify individual parameters to actually make up the cache key. So the more things that we forward to the origin, those things get added to the cache key. And if we're forwarding things that vary a lot, we're effectively reducing our cache hit ratio because the cache key will be different if the values that we forward are different. So we want to try and forward as little as possible. We could forward all the headers, and all those headers will be added to the cache key. And your cache hit ratio is very low at this point because there's so much variability in those headers. And in fact, if you do forward all headers in CloudFront, it won't even be bothered, it won't be concerned about caching that content because the chance of you actually hitting that cache subsequently is very low. So if you forward all headers, you're effectively saying to CloudFront, don't cache any of the content. Effectively act like a proxy back to your origin. There's still benefits for doing that. Typically, you'll see an improvement in latency, but you won't be caching anything at the edge. So generally, you don't want to forward all headers. You want to be specific if you do need to forward all headers. A very common header to forward is the host header. Quite often, you have web servers that are virtual hosting multiple websites. If you don't forward the host header from CloudFront to your web server won't know which website your users are visiting, so it won't be able to serve any content. So it's very common to include the host header as part of your forwarding. That means that this host header will get added to the cache key. It's quite common also to forward the accept language header. So this is the language defined in the browser, the preference for that user. So you could forward that header so that you could vary the response, the language of the response. The one thing to be wary of is accept language isn't just the language of preference. It will give you preferences and an ordered list of preferences. So here, this is my web browser, so it's preferring English British, but it will also accept English US and also just a general English language. But because that gets added as a cache key as is, it does mean if another user comes in, perhaps using a US web browser, doesn't specify English British, they will actually be forwarded back to the origin and they will get their own cached version. So sometimes you want to think about if you do forward headers or you do forward cookies, there are some techniques to try and reduce that variability, and I'll show that later. You can also forward cookies, and this is quite common. I've got an example here. Is obviously, it looks like a session ID. It is a session ID. Sometimes we want to know who the session is, who the user is, so it's quite common to want to forward cookies. And maybe sometimes you only want to forward certain cookies. So for example, you could say that this search page here, we're not interested in the user of the search. The search results won't be affected by the user. However, maybe the theme of the website will affect the response that we provide. And if we're interested in a particular currency, we want the search results to include that particular currency. So it's important to forward when the response is varied because of that particular value. So here's some tips for when forwarding. Try and only forward things such as the headers and the cookies when it will affect the response. As we mentioned before, if you forward something, that will be added to the cache key. If that value will vary over time and over a user's requests, that means you're going to reduce your cache hit ratio. So only forward if the response will be varied and changed because of that value of that you do forward. Also to reduce the variability in forwarded values. So if you're forwarding a header that varies a lot, that means you're less likely to hit the cache with the same values. So only try and forward things that can be reduced in the different types of values that it can return. And that's the accept language scenario that I spoke to earlier, and I'll talk about that later. So sometimes people will forward things such as session IDs because they want to track their users through the website. There are other techniques. You can actually look at the CloudFront access logs and actually track and process the logs directly. Other options is use things such as a beacon. So you don't forward the session ID for the whole web page, for instance, but you forward it just for a little 1 pixel GIF kind of thing. It's a common thing. Or forward just a tracker to actually identify that user, but the whole website itself, you don't forward the session ID, which keeps your cache hit ratio as high as possible. Sometimes people will forward headers and cookies to do authorization and authentication of users. You can do that, but again, you're going to reduce your cache hit ratio. So think about using CloudFront techniques such as signed URLs and signed cookies to do the authorization on the edge. So you can cache and reuse the content that's in the cache for different users, but each user request is still being authenticated at the edge, which reduces the load on the origin. You're going to increase your cache hit ratio, and also the authorization is going to be quicker because it's happening on the edge. And finally, there's a vary response header in HTTP. So this is where the web server will send to its client or any caches that it's talking to. These headers, if you've got different values for future requests, you need to come back and make another request, because I will vary my response if the value of these headers vary. Now you can think of that as very similar to forwarding in CloudFront. The difference being that forwarding is from the request, where vary is being defined by the response. Now CloudFront doesn't actually use the vary header itself. It's already defined the cache key. It doesn't on the request rather than the response. But it's useful to use vary in your origin, because you're telling downstream caches, so it could be the web browser, for instance, or it could be the hotel web proxy, for instance. You're telling downstream caches that if this particular header varies in its value, then I'm going to vary my response. So if there's a different value for a future request, come back to me and I'll give you a different response. So sometimes it's common to want to forward the user agent string. Quite often you may want to, the web server needs to understand the type of operating system or the type of device, whether it's a mobile device or whether it's a tablet, a desktop, etc. So let's say we're going to forward the user agent string. So we do a request against the origin in this case. But the user agent string varies a great deal, and there's a lot of information that probably you don't need to know. You probably don't need to know, for instance, the exact version number, possibly, of a browser. Because there's so much variability, if you forward the user agent string, your cache hit ratio will go down. You're forwarding too much information. You only want, for instance, if you only want the operating system for some reason, then only forward the operating system. However, we can't modify the user agent string. It's defined by the browser. We can't change it of our browsers, users' browsers. So let's think about how we can reduce what we forward. So one technique is to use a cookie. So we can set a cookie, say, for the operating system. And then that cookie's value will only vary between a few operating system options. So because we're going to be varying that value of that cookie, a limited number of values, that helps to maintain the cache hit ratio. But we've got to set the cookie first. So let's say that was one option. I've gone ahead of myself. So one option CloudFront supports, rather than forwarding the user agent string, is to actually forward these headers. Now these headers are specific to CloudFront, and these are one of the things that CloudFront does. If you forward this particular header, one of these headers, or all of these headers, what CloudFront will do at the edge itself will inspect the user agent header, extract the information to define whether it's a mobile device or whether it's a desktop device, and then it will forward that back to the origin. So you can identify one of these devices at the origin without having to forward the user agent string. But let's say I do want to know what the operating system is. We don't have an operating system header in CloudFront. So I do need to look at the user agent string. But what I can do is use a cookie. Let's say we make a request and that cookie is not set, so I don't know the operating system. So I can issue a redirect to the client to go to this unique special user agent URL in my website. So I'm going to redirect the client to that user agent URL. For that user agent URL, I've defined in CloudFront to actually forward the user agent string. Now, I'm only forwarding the user agent string for that particular URL because I need it in the server to be able to define and set my cookie. So the origin now, the web servers, have that user agent string. It can inspect it, extract the information it wants, and then it can send a redirect back to where the client came from and set a cookie. So I've set a cookie here, operating system equals Mac OS X. So I've now got that information. And then for any other requests against that website, that cookie will be returned. And I'm forwarding that cookie so I can vary my response based on that cookie. So here I'm now making requests. The client sends a cookie. I can now define and understand what the operating system is without having to forward the user agent string for every URL on that website. So the way I did this configuration is using cache behaviors in CloudFront. And I've specified for a user agent URL to forward the header user agent, but then for the rest of the website, just forward the cookie OS. So this helps to maintain the cache hit ratio as high as possible, but I'm getting the information in the server that I need and require to do that. But this does feel a little bit like browser sniffing that we used to do 10, 15 years ago in the web browser to understand which browser am I using, what kind of API, what DOM is available in the web browser. So ideally, we should think about responsive web design. Now, this is not a CloudFront feature. This is just a feature of web browsers, HTML, HTTP. But by doing this, we can vary the response perceived by the client. So for this example, this is the AWS homepage. For different devices, it will change the layout of that web page for that particular size of device. And this is all done in the client side. I'm using CSS3 media selectors to actually do this. The good thing about this is it's the same response coming from the web server. We can cache that and serve that to all the devices. And it's the devices that are making that change. So as before, when I talked about including and modifying the response on the client side, again, we're using the client to vary what we present to the user, which makes it very efficient in the cache because it's just one cached object. So 3, the pattern is to validate efficiently. So we can validate. So we talked about validation before, about doing conditional gets, for instance. So where we get an object, but we say, yeah, give me the object, but only if it's a different E tag to the one I've got in my cache now. Sometimes we want invalidation. The idea of being able to invalidate content in the cache. The problem is that HTTP doesn't define invalidation. It doesn't exist in HTTP. So although CloudFront and other CDNs and software will support invalidation, the ability to make an API call to CloudFront to tell it to invalidate this particular URL to take it out of the edge locations globally is possible, but you can only invalidate content at the origin or at CloudFront. You can't invalidate content that you don't in the caches that you don't control. So you can't invalidate content at the ISP or in a corporate or hotel caches. You can't invalidate content in the browser, for instance. So you want to think of invalidation as sort of like the emergency button, the break glass. Something's happened. Maybe you've accidentally leaked your new product too early. So you need to do it. You need to invalidate and try your best to try and wipe that content off the internet. You're not going to be able to do it if someone's already downloaded it into their browser cache. But you can use invalidation for that sort of emergency. What you don't want to be doing is using it as your day-to-day way of handling and invalidating content. You need to think about better ways of doing that. So what are the better ways? Use validation, not invalidation, validation. So validation is defined in HTTP. This is the conditional HTTP request, where we're using things such as if modified. So if the object's changed since this time, give me the current version. If non-match, which we talked about before, using it with E tags. If match is for when you're putting objects to your web server. So if you're using the put HTTP, you can use if match to effectively when you download an object, it's got an E tag, you modify that object and you push it back, for instance. You can make sure that you're actually overwriting the version that you downloaded rather than overwriting a newer version. So if you're using conditional HTTP requests, you want to make sure your origin is actually going to return 304s where appropriate. That's the not modified. If they don't support conditional gets or conditional requests, You could find yourself, as part of the validation, the origin will return the object anyway, even though it's exactly the same as what's already cached in the browser. If it doesn't support 304s, it's going to just send the whole object again. So it's not that efficient. So you want to make sure your origin web servers are responding with 304s where appropriate. And ideally, they should be able to generate those 304s really efficiently. Sometimes you might be in a situation where the web server will make calls to the database, it renders the web page, it constructs a web page, you have to make various calls to various back-end servers to generate that web page, only to find out that actually the version of the web page hasn't changed from what's already in the cache. And you're using CPU cycles and time to actually do that effort. So if you can build your web applications to understand whether or not the object has changed or updated without having to generate it, that makes it really efficiently. So the concept of being able to just look at the database and see, is there a version higher than this one? Yes, it is. Therefore, I will generate that content now. If it hasn't changed, then I won't generate a content. I'll just send a 304, not modified. You've got the current version. Concepts also to use a lower S-max age and a higher max age. So as we mentioned before, CloudFront supports S-max age. This gives you the ability where you can refresh content on the edge locations on CloudFront, but you can still keep the content for longer in the client browser, in the client caches. So that works quite well if you've got content that perhaps, it doesn't matter if users are looking at the old version. Maybe they've already downloaded it. It doesn't really matter. But you maybe want to make sure that any new users coming to your content gets the latest version. So if you set a lower S-max age, it means that CloudFront will more often go back to validate with the origin, but your end users will keep that content a little bit longer. Helps you reduce the cost on CloudFront because obviously they're going to use that content before they come back to CloudFront to get the latest version. And another option is to use URL versioning. So this works well if it's JavaScripts or style sheets. If you change the content itself, you update, change the JavaScript, change the style sheet, you could give it a different URL, and that effectively busts the cache. It will go through the cache because it's a different URL. CloudFront will see that as a completely different object anyway. So that means you can set JavaScript, for instance, the cache control headers, you can set the max age for a year. Because if you're going to, and you will probably change that JavaScript at some point within a year, but if you do, we'll give it a different version number, change the URL, add a v2 onto it, and then the web browser will go to that one and download that latest version. Really efficiently, you can keep a cache control header long, keep it in the cache as long as possible, but if you need to change it, create a new version, give it a different URL. You can't do that for everything. Obviously, you can't change the public web pages and give them a different URL because people won't find them. But for the things that are being referred to in a web page, for instance, or images, etc., then you can do that as well. So the fourth pattern is to automate the edge. So AWS Edge services, they all have APIs. So you can define and make changes to your infrastructure using the edge services, using APIs. We have SDKs have support for those services as well. You can use the CLI as well to make changes and script those changes. You can also deploy changes using AWS CloudFormation. So obviously it's much better to define something in CloudFormation because you can then version control your changes. And you can change the configuration as your application develops. So just like your application will develop over time and you'll add new features, because the edge is part of your application, you should be making configuration changes to your edge services as well as it changes. And it's really powerful to be able to do everything through an API. You don't need to engage with AWS directly if you want to make a change to your edge service configuration. You don't need to engage with AWS professional services. You can do it all yourself through the API, through the console, and through the CLI. And also, you can use IAM to control who can actually make those changes. So that's quite crucial. If you want to control who has access to make changes to your edge services, use IAM to limit access. So it's your CDN, your DNS, and your WAF as code. So this is giving you a very basic, let's say version 1 of your application. So you've got the client on the left-hand side. You're using Route 53 to provide a domain name for which they can connect to the Amazon CloudFront distribution. Using AWS Certificate Manager to manage your TLS certificates. So with AWS Certificate Manager, you can create the certificate and it will deploy that onto your CloudFront distributions. It will also manage the renewal process as well. So once you've created the certificate free of charge, it will manage the renewal and the deployment of those new certificates to CloudFront. You can also use AWS WAF to limit access to your CloudFront distribution, so you can specify WAF rules based on IP addresses or information within the headers or the body, and things such as that, cross-site scripting, SQL injection. And then in this example, we've got a single origin. But perhaps we may want to develop that over time. So we realize, actually, we've got static content on our website, and there are far more efficient ways of being able to store that content. One of those is using S3, obviously. So we can move that static content onto S3, which means when we leave our web servers to do the dynamic content itself. So we can make this change using CloudFormation with CloudFront to make this change as part of our continuous integration process and continuous delivery. An AWS origin, I should say a CloudFront origin doesn't have to be in AWS as long as it's internet accessible. So in this example, we've got an origin in our data center. We can use that as well, and we can make that change and develop the application, and develop and change the distribution, or using CloudFormation. And perhaps this application goes global. And although we're using CloudFront, our global content delivery network, let's say we want to reduce the latency to as low as possible. So we've got an origin in Dublin, but perhaps we want to add a new region in US West 1. So we can add a new region, a new origin in a different region, and then use Route 53 to latency-based routing to route CloudFront to its nearest its nearest origin. So CloudFront edge locations in the US would be routed to the US region, and then edge locations in Europe would be routed to the European origin. Now I'm just going to show you an example. My laptop's gone to sleep. So I've got an example here that I've defined a CloudFront distribution using CloudFormation. So what you're seeing here is using AWS Code Commit, which is our Git hosting repository service. And I've defined a JSON template of CloudFormation. It's fairly simple. At the moment, I've got Elastic Beanstalk as my origin. But at the bottom here, we've got the CloudFront distribution. This is just defining as normal CloudFormation JSON in this example. But at the top, I just want to show you this bit. I've got a parameter here, but I'm accepting a parameter called stage, and I will accept two different values, either dev or prod. And then I'm using a mapping section. So for each stage, I've got a mapping for alias. So this alias is the C name that I want to attach to a CloudFront distribution. So effectively, if I look down here at the CloudFront distribution, for the alias, so effectively the C name I want to give to this CloudFront distribution, I'm going to take the parameter stage and then use that to look in my mappings to find the actual C name I'm going to attach to this CloudFront distribution. I've also defined two other JSON files. So this one is parameters. So this is a parameter that if I use this JSON file as a parameter file, I'm going to define this to feed it into CloudFormation. So I can set that my stage is a dev, and you can see there was a prod one as well, so I can specify it as a prod. So I can make changes to that CloudFormation template. I can commit that into my code commit repository, but I need to deploy that to CloudFront. So what I've used here is AWS Code Pipeline. So Code Pipeline is a CI pipeline, continuous integration pipeline. I've got a source there, which is the code commit repository. And what happens is when I commit something into that repository, Code Pipeline will pick up that change. And from there, it will take that information. So it will take the template and the 2 JSON files I've defined in my repository, and then feed it into the next stage called dev. And in dev, I've defined a deploy category, action. And I'm using the deployment for AWS CloudFormation. So this was only recently released a few weeks ago, I believe. So this is a way of using CloudFormation as part of your deployment. And in here, I define the stack name that I want to deploy it to, the template I'm going to use, which is in that code commit repository. And I've also defined the template configuration. So that means when Code Pipeline runs this deployment in CloudFormation, it will pass it the template, but it will also specify that take the parameters from that parameter file, the dev.json parameters file, and pass that into CloudFormation. So CloudFormation will know that this stack has got a parameter of prod for stage, therefore it will specify that particular alias within the CloudFront distribution. And once I deploy that to my dev stack, I can then check that that's working in CloudFront. I haven't shown a testing stage here, but it would be common to have a testing stage just to make sure that your dev CloudFront distribution is working fine and there's no problems. Before you can move to the next stage, and that's to deploy it to production. So I've created a manual approval here. So I can do my testing, I can do my manual testing, making sure that the new dev distribution for CloudFront is working exactly as I want it to do before I do approval to prod. And when I hit that button to review the change and to approve that change, it will then deploy it to my production stack, which is my production CloudFront distribution. And so the CloudFront distributions there'll be 2 CloudFront distributions that each are a member of a CloudFormation stack. But the 2 CloudFront distributions will have their own CNAME, their own alias, so I can test those individually, separately. In this example, obviously because I've included the Elastic Beanstalk application as the origin, I've effectively got an origin per distribution as well. So sometimes you could create a CloudFormation template that defines everything, the whole stack. So not just CloudFront, but also your configuration of your origins, etc. And it can be part of your deployment process. So it's quite keen to think about how you can deploy your CloudFront distribution, your CloudFront configurations and your edge services such as WAF and Route 53 as part of a CloudFormation template. And using Code Pipeline, you can have a pipeline to deploy those changes to your development stack before you go to your production stack. One other thing of automating is to think about using AWS Lambda. Now, obviously, we launched Lambda at the edge, so that's another benefit of thinking of your edge as part of your application. You're now able to execute at the edge now effectively, so you can make modifications to your requests and your responses in the Amazon CloudFront itself. But in this example, I'm talking about AWS Lambda making modifications to your WAF configuration. So if you go to our website, we've got pre-configured automations for WAF. So these are things that we've created for you, which gives you, they can be used and deployed, but it also inspires you to think of other ways of managing your WAF configuration. So it gives you examples such as IP blacklisting for reputation lists, for instance, or perhaps looking at for bad robots, or possibly bad actors that are looking to try and exploit your website and are finding errors in your website, and you can see those by looking at your CloudFront logs, and therefore blocking those users, perhaps that are trying to find an exploit in your website. So the final pattern to talk about is to monitor the edge. So we're automating the edge, but we need to monitor it as well. So Cloud Trail is supported in both Route 53, CloudFront, and WAF. This gives you the ability to detect any changes, configuration, or any attempts to make any changes to your edge services. Amazon CloudWatch has metrics and alarms for those services as well. So it's quite useful to be able to monitor those those metrics coming from your edge services, just to make sure, is there any change in expected behavior? Perhaps if I see my requests going down on CloudFront, maybe something's happened, or maybe if my errors increase, maybe my origin is having issues. CloudFront has its own reporting as well, so these are available in the console. But we've also got access logs for CloudFront. So the access logs themselves are just text files, so they're normal web logs that you would see from web servers, etc. But Amazon CloudFront will deliver those into an S3 bucket of your choice. So by default, CloudFront distributions are not enabled for logging, so you need to enable them, and then you can define an S3 bucket to deliver those logs. The logs we talk about in the documentation takes within an hour. It can be quicker, but they get delivered within the hour into an S3 bucket. What you could think about doing is using Lambda with S3 bucket notifications, so that when a log file is delivered into S3, you could take that in Lambda, and perhaps you could enrich that or add more information to your logs. Perhaps you've got extra information from your own database of logging user information. You could attach those to those log entries to enrich that data, deliver it back to an S3 bucket, and then you could use Amazon QuickSight to be able to analyze that data. You could also deliver that into Amazon CloudWatch logs. So although CloudFront doesn't deliver it directly into CloudWatch logs, you can use Lambda to take those from the S3 bucket, deliver into a CloudWatch logs, and from there you can start to build metrics and alerts based on those logs in Amazon CloudWatch logs. You can also use AWS Data Pipeline to take that data and deliver it into Amazon Redshift for other processing, as an example, into using Amazon QuickSight. And then finally, because they are just web logs, text files, you could use your favorites, your preferred W3C log processor. So those are all the patterns for the DevOps Edge. So there's 5 there in total. One thing I want to talk about is the key takeaways from this session. So think of the AWS Edge services as part of your application. Don't think of it as something that you might add at the end of your project. Think about them, how you can use them in your application to provide a better user experience. We've now got Edge Lambda at the edge. We can start to think of how we can use that at the edge as well. Try and optimize and use caching efficiently. So think about how you can vary the cacheability of an object, not just down to its own, the actual URL that it's using, but also the time. It can vary it over time for different requests, for different reasons. Automate the configuration of the AWS Edge. Although you can do this all in the console manually, you're not really documenting what your changes you're making, and it's quite hard to repeat that. So use things like CloudFormation to define your edge services, and then use things such as code pipeline and code deploy to deploy those, use things such as code commit and code pipeline to deploy those CloudFormation templates to your stacks. Then finally, to monitor your AWS Edge using Cloud Trail, CloudWatch, and services logs. So that's the end of my presentation. If anybody's got any questions, we've got 6 minutes. Just a couple of things. Please, can you remember to complete your evaluations? That's really valuable to us, for me personally, to understand where I can improve my presentations. So it's really important to give as much feedback as possible. There's also some related sessions. So there's 2 sessions showing here on the tomorrow morning. And that's the end of my presentation. Is there any questions? There are microphones there if anybody wants to speak. Okay, thank you.